up guys, welcome to my new video, and in this video we will see what function overloading and function overriding is. So let us look at an example for it. So this image gives us a clear understanding of what the concept is. So in overloading we have these three arrows, alright, unlike overriding where we have only single arrow and the second arrow is being combined with it. So keep this image in your mind and let us look at an example for it. So if you have been following my videos, so in virtual table video I have used the same example. The only difference is I have added the overloading code in this. Alright. So in the example we have this base class and we have two derived classes, but we are just using the single derived class in our example. Alright, so we have these two virtual functions f1 and f2, and f2 is being defined. Then we have this derived class d1 which inherits base class publicly and it overrides the first function. Okay, so what this means is if the function one definition is there, which is there, I have not written anything in this, but if it is there, it overrides that definition with its own definition. Alright, so here it is. So it displays d1's f1. Alright, next we have these four functions with the same name, but we have different parameters in it. So for example, this add has two floats as parameters, then the second has two double, third has two integers, and the final has two characters. So the logic behind this is you don't need to remember different names, as simple as that. For example, I could have written this add as add float and this as add double, or this as add integer or add character, but it makes the task bit difficult. Alright, it makes it bit difficult to remember all the names. So the overloading concept makes it easy for us. It makes it easy to remember the name. So now you just need to remember this add and you need to forget about the parameters, but those parameters should be between these functions only. So you cannot define a object or you cannot pass an object to this because we don't have a function for it. Alright, then we have this d2 class which inherits base publicly. Okay, now let us look at what we have done in this int main. We have d1 class and we have this base pointer which points to this d1 class. We are calling f1. So this is late binding. What it means is the call is the call to the function is decided when the program is actually running. Alright, so until and unless we don't run the program, we don't know which function we are going to call. Alright, but if you look at this add function, we know which function we have to call because we have this parameter and the matching has been done at the compile time itself. So this is called as early binding. Alright, now what will happen is this will call the f1 function which is here. So the output would be d1's f1. Alright, and next it will call this different add functions and we'll get different output for it. So let us see what the output is. Look, d1's f1 addition is 3.3, addition is 5.4, addition is 3, and this is AK. So this last four output of the four sentences are from the overloaded functions, and the first one is from the overridden function. Now let us change the code a bit. Alright, so let us create an object for d2 class. Let us point this to d2. Now what will happen is it will call D2's function, but D2 doesn't have a function. So let us F1 function, let us call this F2 function. Alright. Now it will call this function at runtime. It doesn't know when we compile the code. Alright, so let us run this. As you can see, D2 is F1. Alright, so this is it. This is how it works. Thanks for watching, guys, and if you got something from this video, do click on the like button, share this video, do subscribe to my channel, and thanks for watching.